What is going on, fellow chemists and the internet? Today we are going to be doing some chemical reactions and chemical experiments in Zan's lab. I'm Xander, that's Zan's lab, and basically, we're just going to have a lot of fun. We are going to be doing some simple projects with things that you can find at home and you can do just as well as I can. These are things such as vinegar, bleach, things that we use in cooking and cleaning, everyday objects. Now, I hope you have a wonderful time. Watch to the very end because I do want to discuss something about one of the experiments in the video. Now, I'm going to cut to the next clip. See you then. Hi, this is the first experiment of the day. We have some sodium bicarbonate, better known as baking soda, and some vinegar. Now, you probably already see what's going to happen, but first we're going to take this white container and we are going to fill it with some baking soda. Now, the next thing we're going to do is we are going to grab this container and fill it with the vinegar, and then you're going to see a very cool reaction. Now, this produces heat and a new chemical known as carbon dioxide. Now, when this ionic bond forms, it releases the energy as heat and also creates what I just said, CO2. That is the first experiment of the day. I hope you enjoyed. I'll see you in the next clip. Our next experiment will involve vinegar, hydrogen peroxide, and aluminum. Now, the aluminum isn't until after we have created the first chemical, so we're going to put this out of the way for the beginning. Now, first thing we're going to want to do is we are going to take some of the vinegar, and we are going to pour some of it into the container. Now, it doesn't have to be exact, because this is just an experiment to showcase the properties. Then we're going to take some of the hydrogen peroxide, it is 3%, and we're going to pour some in here as well. Now that we have done so, this has created a chemical called parasitic acid. Now, whenever you mix it in a 1-to-1 ratio, it should create parasitic acid, which is very corrosive and deals major damage to aluminum. Now, not only aluminum, but metals in general. Now, that is what the aluminum is for. I'm going to take the aluminum, we're going to drop it in, and now we're going to watch and see what happens. If what I did is correct, it should start bubbling, and it should create a change in the aluminum. The hydrogen peroxide and the vinegar, they combined, but I think it just made a solution. I don't think it actually combined chemically. There wasn't an expulsion of heat, there wasn't any gases released, and there was no sign of chemical change. And also the lead and the aluminum that I added didn't exactly change. And like I said, I think it's because I didn't add a catalyst to actually start the reaction. So we're going to come back to this in a later video, and we are going to try and see if we can recreate this experiment, along with a couple of other more dangerous experiments that produce gases and things that you really don't want to breathe in. Our next experiment is going to be another simple one that we have all seen before. It is the Dr. Pepper and the Mentos. Now, first thing we're going to do is we are going to want to find something that we can put the substance in that is not going to overfill. I'm not going to pour too much because, like I said, my lab station isn't exactly the best. We're going to put the Mentos in, open up the unopened Dr. Pepper. Now, I would prefer it to be unopened so that the CO2 is maximum. And, we just pour a little bit in. And as you can see, let me crush this up a little bit. As you can see, once I crush it up a bit, and I pour some soda inside of it, it fizzes vigorously, and that happens. Now, if I were to pour the Mentos into here, what would happen is it would create an even larger fizzing, and I will demonstrate that now. I really hope this doesn't get out of hand. So I have the Mentos here. I'm going to pour one into my hand. Now, I'm going to drink some of the Dr. Pepper so that, actually I give it to my lovely assistant Axon. He's going to drink some of it so that it doesn't overflow too much. Alright? Now that some has been drank, we're going to drop that in there. And as you can see, it fizzes vigorously.
Volcano!
And it makes a cool volcano. Now, give me a minute so that I can clean up this mess and I can show you the next few experiments. See you in the next experiment. Our next experiment will involve some sodium tetraborate, which I believe is borax, and some glue, and some food dye. We're also going to be using some drinking water. Now, first thing we're going to want to do is open up our sodium tetraborate, hopefully not spill it everywhere, and we're going to pour it into this container. Now, once we have poured it into this container, there's our borax or sodium tetraborate. We're going to open some water, and we're going to create this solution. Now, the glue has a larger molecular structure than the water or the borax by themselves both do. And we are going to mix this up together to create... Wow, would you look at that? Now, as you can see, this is a very, very, very gooey polymer. The polymer is able to stretch and able to hold a shape and not lose it by itself. We're going to grab some more of this. Now, Axon, if you would like, you can pour the food coloring in.
I would.
We're going to open it up and you can pour it in. Now, the food coloring is purely for aesthetics. It doesn't have anything to do with the actual structure of it. And now we're going to mix it together, create this cool purple slime.
It's slime.
Pretty cool, huh?
Mm-hmm.
Now, this is a chemical reaction. It's not just something that's cool that's happening. It is, in fact, a chemical reaction. It's a different chemical reaction than a lot of people would expect it to be.
Can we put anything in it and then leave it out and then leave it to harden?
I don't know. I don't know the properties of this borax water glue polymer. I actually got this out of a science experiment little packet, and that's why I had the sodium tetraborate in that cool little packet.
Would you like to try to put something inside it, like one of those BBs down there, and then let it harden?
No. Alright, so I think that's the end of this experiment, but as you can see, it is a very flexible... At this point, it's not even liquid so much anymore. When you pull it apart, it's more like a waxy substance. It's not exactly waxy. It's like silicone before it completely hardens. Yeah, it's actually very, very similar to silica. Alright, here, Axion, you can take 1/2 and you can...
No, I don't want my hands to get dirty.
That is the result of this experiment. I hope you enjoyed the experiment. Now, we will continue. This is post-experiment, but there seems to be some of the tetraborate left in the container that wasn't absorbed, so I guess there wasn't enough glue in the container. I mean, there's still some glue left, so I guess we could do it again. But I think this is cool because if we pour the rest of the glue in here, right? As you can see, the glue is very easy to pour. Anyways, continuing with the experiment, there's more glue left over and more tetraborate left in here, and I didn't get a chance to pour all the glue in here, but I just wanted to see if the tetraborate still had the properties of creating this polymer. And this time I'm not going to use my hands because I'm not in the mood to get more dirty. Here, Axton, you can come mix this up.
Oh.
This is my lovely assistant. A wonderful mixing. I'm going to set the camera down so that we can see the mixing of this. And as you can see, once again, the substance has become glunky and very, there doesn't seem to be much tetraborate left in the container, but this is an experiment that I think that if you do have borax and glue, it would be a lovely experiment. This doesn't create too much of a mess as long as you don't use food coloring. My station is completely covered in purple, but as long as you're careful not to spill any of the tetraborate, it's a very clean experiment. I think that if anyone wanted to, they could try this experiment. So yeah, we are going to move on to the next experiment finally, the last experiment. And yeah, I just wanted to show you that there was more left over, so yeah. Okay, so another post thing. If you don't squeeze it, there's more glue inside of this tetraborate polymer. Like you can see the tetraborate polymer, and it's very consistently not sludgy, but when you squeeze it, there's glue inside of it. So it basically bonded and created that cool molecular structure that I was talking about, the polymer, kind of like silicone, but on the inside, it hadn't reacted with the tetraborate. So the glue on the outside reacted, but not the glue on the inside. So when you squeeze, there's even more glue on the inside that didn't get a chance to react. How cool is that? So not only do you have to mix it in, but you have to squeeze out the excess glue if you want to get the full amount of slime silica type thing that is in here. And I don't think this is silicone, but it has a silicone type property. So don't say that I'm saying that, oh, he said it's silicone. He's lying because I am a chemist. No, I'm not saying that it's silicone. I'm saying that its properties are kind of like silicone in the fact that the molecular structure is very large. Alright, so this is the legitimately last part of this experiment. I'll see you in the next one. So, for our final experiment, we are going to be using bleach, hydrogen peroxide, or H2O2, and I'm going to be using this glove to simulate a way to hold the gas that is released, and a bottle. Now, the gas that will be released is not poisonous. It is hydrogen and oxygen. It should release more oxygen than hydrogen, I believe, but I am not certain. Anyways, hydrogen and oxygen are not poisonous gases. However, we do not suggest that you use any flammable things near this experiment because hydrogen is flammable, and so is pure oxygen. The glove is simply to contain the gas to show you that the gas is coming off. You should be able to see it with the bubbles anyways, but first things first, we are going to put this in the sink because I am not trying to ruin any of the tabletop counters. We're using two different types of bleach. Just in case one of them doesn't work, I'm going to use the kind of regular one-ish first. This isn't the normal one, it's just Smart Seek. I'm not sure. It does say that it contains the chemical that we need. I'll explain what that chemical is later. But we're going to pour that on first. Now what we're going to do is we are going to set this up right here. I switched camera views so that I could show you this. We're going to be pouring the hydrogen peroxide inside of the glove. I don't think that hydrogen peroxide is corrosive, so it shouldn't eat the glove by any means. Now that we put it in here, we're going to take this over to the bleach. And we are going to first place the mouth of the glove over the bleach container. And then secondly, we are going to pour the hydrogen peroxide in 3, 2, 1. Now, as you can see, there is a chemical reaction going on, and the glove has started to fill up. This is because the gas that is released from this experiment, as I previously stated, is oxygen and possibly hydrogen as a byproduct. Now, as you can see, this isn't just, it's actually full of gas, which should be hydrogen and oxygen, which should be safe to breathe. So this is something you can do at home. I would suggest wearing gloves because, it is bleach, but as long as you aren't constantly being exposed to the bleach on your skin, and as long as you definitely don't get it in your eyes, you should be fine. We are going to proceed with this experiment again, but this time we're going to use the splashless bleach, which I'm not sure if it'll work the same, but I hope it does. Now, we have the same setup again, but this time, instead of using the smart bleach, we're going to put this over here and cap it. We are instead going to be using the splashless bleach, which I am actually not sure what's going to happen. It should create the same effect since there has the same substance, but we're going to pour the bleach into the glass container first. And why are we putting it into the glass container first? Because if we were to pour the bleach into the glove would eat the plastic, and that would not be very contained. So I'm going to give us another camera shot and then show us when we're refilling the glove. We again have the glove and the 3% hydrogen peroxide. We are going to fill up the glove with the hydrogen peroxide. And the hydrogen peroxide, as I before said, isn't corrosive, so it's not going to eat it. Now, let's get some more in here. I actually want to see how much of a reaction we can get from this. And as you can see, the fingers are filling and not the glove itself, because the fingers are the glove. Okay, now we're going to switch camera views. We're going to bring it to right over here, and we are going to again put the sleeve over first. Then this time I'm going to grab all the fingers and pour them all in. And as you can see, there's been a massive reaction. Major bubbles have formed, and they're continuing to rise for now. I'm going to see if I can get any more of the hydrogen peroxide in there. Now, there has been a reaction, but I'm not sure if the same amount of hydrogen and oxygen have formed. There is more bubbles because I poured more hydrogen peroxide in, so that's not conclusive to say that there is a difference because of the splashless bleach, but it has created a tiny bit of heat from the reaction, which I think is pretty cool. Now, as this is the last experiment of the day, I ask you that you all leave a like, subscribe, have a wonderful day, and if you do wish to try these experiments at home, learn something from them. You know, they're fun, but the purpose of these experiments is to learn. So, yeah. Have a wonderful day.